Hello everyone, welcome to our channel Physi Dive, and this is your teacher Alexi Rajan. Today we are going to study a few topics for class 10 CBSE NCERT, that is defects of eyes and how we can correct those defects. So without wasting time, let us dive in straight to the class. So to the class. Defects of eyes. So here we are going to deal with some of the defects of eyes, and there the first defect of eye is myopia. Second one is hypermetropia. And the third one is presbyopia. And the fourth one is astigmatism. So in this class, we will deal with the first two terms, that is myopia and hypermetropia. And this myopia can be also termed as short-sightedness. And hypermetropia is known as long-sightedness. So the first term is short-sightedness or myopia. So what is this myopia? So normal human eyes, I'm just representing the normal human eyes like this, and then we have a natural lens inside our eyes and a convex lens, more precisely. Now what happens is a normal eye can see an object which is around 25 centimeter in front of the eyes to infinity. That is, I can differentiate an object which is kept 25 centimeter. I can also see the object which is beyond that or near to our eyes, even near to less than 25 centimeter, but I cannot differentiate that points clearly. So we call it as a near point. For a normal eye, the near point will be 25 centimeter, and it is known as the near point. Again, I'm saying, what is this near point? If I'm just taking a paper and you just take a paper and then you just what you want to say is you just put two marks nearby, two dots there, and you just keep your eyes paper like this and just move it closer to your eyes, and the nearest point, okay, the nearest point at which you can differentiate these 2 points clearly is known as what? The near point of your eyes. And the far point will be always infinity. So infinity is considered as the, so that means you can see any object which is kept at the infinity. This is what the far point means. Okay, now in the case of a myopia, you can see that if I have myopia or anyone have myopia, then you can see near objects. That means the object which is kept near to your eyes can be clearly seen. But if something is there at infinity, if this is your eyes, and if something is there, a tree, or is somewhere at far point, okay, then your eyes will not be able to differentiate or give a clear clarity of this particular object. Okay, instead you will get a blurred image. So this condition, but this man with a myopic eye, will clearly see the object which is nearby. So he can see this tree clearly, but this tree in a blurred way. So this condition is known as what? Myopia. So how this myopia occurs? What is the actual reason for this myopia? This is the next question in front of us. So there are mainly two reasons for this myopic eye. And the first reason is that a high converging power of your eye lens. So what happens is, if you have a myopic eye, it looks like this, okay, and you have a lens here, and the object is at infinity, because for a myopic eye, it is very difficult to see the object at infinity. So any object is kept at infinity, and it can be represented pictorial. In which way? We have already studied this thing, that is, the light rays coming from the infinity will be parallel rays. Okay, it looks like this, parallel rays, and you can see that the lines are coming parallel. Why? Because the object is, these rays are coming from the object, and this object is at infinity, so the light rays will be parallel to each other. After these rays falls on this particular eye lens, what happens is it converges, and usually it should have converged and fall on your retina. This is your retina. This part is known as retina, and retina is where the image is formed, and it is the optic nerves will take that image or image signals to your brain, and it will process there, and you will see the object. This is what happens there. But here what you can see is that is for a normal eye, but for a myopic person, what happened is this, instead of falling on this retina, the image will be falling in front of the retina, in front of the retina. That means the image will be formed somewhere here. Instead of falling, or image should fall here, the image will fall somewhere here of your lens. High converging power of your lens is one of the major reasons of your myopia. And what is the second reason? And the second reason is nothing but a large eyeball. If you have a large eyeball, it's a genetic thing. Large eyeball, what happened is usual man's eyeball will be like this, okay, an average. Then what happens is the light rays will come from infinity, they will converge and fall somewhere here. Just imagine that instead of having this usual size, if a man is having a bigger eyeball, then obviously what happens, the converging will takes place, and then it will just converge and form somewhere here. Here also you will have the same defect. That is, these are the two major reason for this myopia. So I hope that you got the major reasons for myopia. So a quick revision. The first one is, what is myopia? Myopia means short-sightedness, and a person with myopia can see the object which is kept nearby, but he cannot or she cannot see the object clearly which is kept at infinity point or far point. This is known as myopia, and this is also known as short-sightedness. What is the reason? What are the reasons? There are mainly two reasons, and the first reason is that high converging power of your lens, and the second reason is that a large eyeball will cause you myopia. Okay, so how can I identify and rectify? Okay, I already identified my myopia, but now there is a point in front of me how to rectify this particular myopia condition. So we'll see how we can rectify the myopia condition. Okay, we'll see the correction right now. So in front of us we have two eyes. One is a person who is having normal eye, that means without myopia, and the second eye is with myopic condition, that is myopic eye. Okay, now we'll see that here for a normal person the near point will be somewhere here, that is the near point is 25 centimeter, and for a myopic person also the near point won't change. Why? Because he can also see the object which is near to their eyes, and the near point won't change. For a myopic eye also the near point is 25 centimeter. The issue is the far point in the case of myopia. Now you can see the object is kept at infinity, so the light rays from the object will be falling parallel to each other, and then they will converge and they will fall the retina. So for a normal eye everything is clear, crystal clear, no issue is there. But for a myopic eye the issue is with the far point. Now you just see, okay, the object is kept at infinity, the light rays are coming parallel to each other from the infinity, and they converge and falls in front of the retina. So this is what happens for a myopia. So what is the solution for this? The solution is nothing, a simple logic. The logic is that you should keep some lens, preferably which lens? A concave lens, not a convex lens, a concave lens. And concave lens is which lens? Is it diverging or converging? It is a diverging lens. So what happened here is that I'm just using a different color here. So you can see that after diverging from this convex lens, it just falls like this. So you can clearly see that it diverges and falls on your eye lens. If you extrapolate, you can see that this extrapolation is going and falling on this near point. That means the image of the object, which is the actual object which is kept at infinity, is falling in your near point. In fact, you can easily see the near point, and then your eyes can easily see, you can easily see the object as it is falling at the retina. So here also the same thing happens there. The object is kept at infinity, and then you use a concave lens, and then your concave lens will just diverge. In fact, they will just clearly form the image of the object in, or it falls on your near point, and then in fact you can see that object also clearly. So your correction is nothing but use a concave lens of suitable power. The next defect is hypermetropia or long-sightedness. A patient or a person with hypermetropia can see the far object clearly, whereas the near object cannot be clearly seen. And this condition is known as what? Hypermetropia. Our parents usually read the paper like this. Yes or no? Have you ever noticed that? It is like that. Why? So this condition is known as what? Long-sightedness. Long-sightedness. That means they can see the object which is kept at far distance. For that's why they are saying that long-sightedness. Don't get confused. It is long-sightedness. The sight is easily seen at a long vision. It will be there. So we'll just see it in a clear way. So we had seen what is this hypermetropia. Now, how it happens. In the case of hypermetropia, the issue is with near point. It's not the far point. There will be no issues with the far point, but the near point, there will be some issues. Okay, let us see. This is our near point for a normal eye. That is 25 centimeter from the eyes. And far objects, the light rays from the far object will be falling parallel. There will be no issue there, and it falls like this. It falls without any difficulties. Okay, no issues there. But what happens if something is kept here? Light rays falls, converge, and it falls somewhere at the back side of the retina. At the back side of the retina, here is it just converges and falls at the back side. So there also you can see, you cannot see the object clearly. But if you just shift this near point, there is a near point for a normal eye. Okay, if you shift this near point somewhere here, then what happens? You can clearly see the object will, the light rays will fall somewhere here and somewhere here, and then it converges and falls at the retina itself. Okay, I think that I had made it more messy, but there's an excuse for that. So you have to shift your near points a bit backward, or somewhere at suitable backward position, so that it falls on your retina clearly. This is the reason. Okay, what are the reasons for this hypermetropia? The reason is nothing, just opposite of this short-sightedness. And the first reason is low converging power of your eye lens. The second reason is that small eyeball. So if you have a small eyeball, what happens? Instead of having, okay, if this is a normal eyes, okay, this is a near point of a normal eye. It just goes there. It's an eye lens. It just goes there, and it just falls on the retina. There's no issue. But instead of this normal eyeball, if you have an eyeball which is smaller than the usual case, what happens? Here also, you can see that the image is formed at the back side, this side, right? So there is an issue with this size of the eyeball. So these are the two reasons for this hypermetropia. So we'll see that how to correct this hypermetropia. So we'll see the correction right now. So these are the two eyes. That is, the first one is a normal eye and the second one is a hypermetropic eye. So let us see what happens here. In the first case, you can see that if this is a near point and if any object is kept at a near point, the light rays will just comes from that object. It falls on your eye lens, and then it converges and it falls somewhere here. Okay, so then you can easily see the object clearly. Okay, in the same way, if I'm keeping the object at a normal near point, that is 25 centimeter, what happens is it just falls, I'm just using a dotted line, falls somewhere at the back side because of the low converging power. But instead of that, if you just keep another convex lens, it goes there, then it converges some more, and again converging takes place and it falls at the correct position at the retina. So here the actual correction is made by using a convex lens of suitable power. So usually what happens is it converges, and then if you extrapolate, the actual reason is like this. If you extrapolate, it just falls on the points. It just imagine that if you just keep a convex lens here and it converges and falls in such a way that if you extrapolate those converging lines, then you will see that those lines are falling on the point which is the near point of the hypermetropic eye. So using a convex lens of suitable power, you will be easily correct. You can easily make a correction on this hypermetropic or hypermetropia condition. So this is how you are just correcting hypermetropia. I hope that you understood the reasons, the condition, and the correction of both diseases, that is myopia and hypermetropia. I hope that you understood those topics of myopia and hypermetropia. We'll come with a new class which gives a detailed study of astigmatism as well as presbyopia in the coming classes, and we need your support in terms of your like, share, comment and subscription. So till we meet again, it's goodbye.